geography, human geography, in the Faculty of History and Geography. And I belong to the group TGs, the one that you see in the upper part of the presentation. This is a group that is specialized in transport infrastructure, mobility. We also look into urban planning issues. And our main tool in this group is geographic information systems. Before talking about defining what is a geographic information system, I will show you a couple of examples. This is from a very popular newspaper in Spain. It's called El País. And here they show the outcomes of the elections. Another example is Foursquare. It's very similar, the idea. And here with the novelty that you also have the social networks, so you have the opinions of your own friends. But the idea is mostly the same. You have a map, and you have all sorts of establishments. And this is another example. This is a service from Google Maps. So here we have a map, and we can ask a service of calculating a route. This is like Instagram, and this picture is geolocalized in one place. So at the end you can see a map, and you can see all the different pictures people uploaded to the system. And this again, there are a lot of information behind this map. This is very interesting application. This is a web service that shows you the 1 million tweets. What does it mean? I don't know if you know, but Twitter provides free data. So you can download 1 million tweets. Let's say 1% of the tweets, between 1 and 5% of the tweets, of the total tweets per day, you can download it free. So here what you have is a circle with the number of tweets in that area that is changing constantly, and the size of the circles is proportional to the quantity of tweets. But also what you can see is a heat map. There is a different kind of visualization. So here you don't have numbers, but the magnitude of tweets is shown by colors. So in the red spots, they are highest quantity of tweets. This is very nice visualization because you see how these lights are popping up depending on the time. So they start at 10 o'clock when shops open, and then there is a boom of activity at the middle of the day, and then they go down as well. These OpenStreetMaps, I don't know if you know this project, but this is a collaborative mapping. So everyone that wants to start mapping, you can create an account, a free account, and then you have on a web service where you can start drawing. After giving you some examples that you know, or most of them, I will define what is a geographic information system. So this type of systems work with geolocalized data. This means that we have maps with several elements that have a representation in space. They have geographic coordinates, and associated to these elements we have attributes. And these attributes are stored in a table. So we have maps, and we have a table behind the map that most of the times we cannot see it. We also have a hardware and a software to do this geographic information system, and we have a lot of tools. Depending on what you want to do, you have many tools that you can use. So at the end we have a layer, we call it a layer, but in other programs we call it something else. So we have a layer of information where we have a map and we have a table with attributes. And each layer has a geometry. That means that it has a physical definition. For example, it is here for a layer of road network, let's say. A physical definition would be the lines that define each road. And we have a coordinate system because maps are a representation of reality. So we need a coordinate system to represent these elements in scale. And we have a thematic table where we store all the attributes of our elements in map. GIS have two ways of representing data. We have a vector representation that is very powerful, and here you can represent data with points. For example, you have points to represent firms or shops and metro stations, for example. You can represent information with lines, type of information with lines, so you have streets, metro lines, or you can use polygons to represent, for example, census tracts or regions. So this is the kind of data that you can represent with a vector geographic information system. There is another way to represent data that is raster. Raster is, for example, satellite images or pictures or digital elevation models where we have the altitude of places. Or we have population as a grid, so each pixel has a value of population. We have many tools in this type of softwares. So, for example, we have tools for conversion, different formats, so we can use data that is coming from different sources of data. We have projections to represent our data. We can edit the data, so for example, when I told you about the OpenStreetMaps, here we were drawing the lines, we were mapping, so all these tools are part of edition tools. We can overlay and aggregate data. This is very interesting for analysis of data, and we can measure, we can do spatial analysis, and we can look at the connectivity between elements in our maps. I will now show you what we can do with GIS. These are a couple of examples. For example, we can map events. This is from the Center of International Earth Science Information Networks. And in this map, you have represented several types of events. So you have earthquakes, you have fires, you have flood warnings, you have tornado warnings, and also as additional information, you can. They also draw dam, they also draw nuclear plants, and they also put the population. You can use GIS for geomarketing. And what is this? So you can use GIS to identify the key opportunities in marketing strategies. For example, Correos is the main post company in Spain. They have a very important strategy that they sell to help companies to look for their customers, where they are located potential customers as well. They also can help you to plan routes for your business. to see service areas. Another topic that is often analyzed with GIS is health. Here is the World Health Organization, and they recommend the use of maps for different kinds of studies. So, for example, in the upper part, you have the child mortality, and they cross it with agroclimate zones. So they can see that if there is a relation between zones that are poor in terms of agriculture with child mortality. For transport, GIS is also very useful. So, for example, in the first map, these are the bicycle stations in Seville. And this is also a dynamic map because you can see how many bicycles are in each station at each time of the day. So these numbers are changing. Then this other one is the information from EMT, the buses from Madrid. This is a study where we analyze the distance to public transport stations. So these dots here are the public transport stations, and we want to see which area is within 30 minutes from the public stop. Here we were looking at the opportunities available within 30 minutes from every space. Here opportunities we take as a population. So if you think of a businessman that want to see which area has the highest population concentration, he would use this type of outcomes, let's say. What we are doing these last years is to use other sources of data, for example, Twitter, and we also using TomTom, data from TomTom. So with Twitter, we can see where population is, and this is changing depending on the times of the day. So if you are in the city center, you have much more population in the afternoon, for example, but less population during the morning, at the first hours. This is an example of the impact of congestion in London. Here you have, in the vertical axis, you have travel times, and you see how travel times get bigger when congestion is higher. So, for example, now it's less travel time, but starting the rush hour around 6 o'clock, the travel times expand, which means that it takes longer to reach the city center because there is congestion. This is an European project that ended a couple of months ago. An European project from Horizon 2020, where they were looking at several cities in Europe and comparing, in this case, they were comparing the integration of different nationalities within cities. And they came out with very interesting results. They came out with a classification of cities. For example, the first ones here, the blue ones, London, San Francisco, Los Angeles, and Manchester. They had similar patterns of Twitter. I forgot to say, they were analyzing this using Twitter as a source. And within Twitter, they were looking at the language of Twitter. So they could see if a person was from a certain nationality with this data. So they looked at the different cities, and they show, for example, that London, San Francisco, Los Angeles, they are there are cities that integrate a lot of cultures. They have a lot of diversity, and the people from different nationalities are well integrated according to their analysis. Another source that we are using to analyze urban pattern is Airbnb. Airbnb, we use this data in Barcelona. Here my colleagues were doing this study comparing the regular accommodations, so let's say hotels, hostels, so legalized accommodations with Airbnb. And here they provided a statistical analysis, but what this means is that the red spots, we have a high concentration of regular accommodations, but also high concentration of Airbnb. And the most interesting thing is this light blue here. These are areas where regular accommodation are low, but Airbnb is getting high. So here are the places, the residential areas where you cannot find hotels, but there are a lot of apartments in Airbnb. Another thing, and I'm getting close to the end of this presentation, I want to talk to you is about software. Which are the softwares that you can use for doing this analysis? Well, the main one and the most commercial one is ArcGIS from Esri. This is a US company, and we are using this software in this university. We have agreements with them, and we have this software installed in different rooms in geography history faculty. And this is very popular because it's very big. It's, you have everything. You have a lot of tools that you can use. And you have great help in internet as well, a lot of forums, and also the resources provided by this company in terms of help to understand how GIS works are very useful. The other one, Mapinfo, was very popular a couple of years ago, but now is not so popular. I think that the Esri ArcGIS won this contest. There were a time where both were competing and more or less equal, but now ArcGIS is very much popular than Mapinfo. Idrisi is another one, but this one is mostly used for raster data. Remember I told you about different type of data. We have vector and we have raster. So if you want to work with the satellite images and this type of data, so Idrisi has many tools. And here I put it also the open source GIS. So we have GVC, Quantum GIS, Vast GIS, and CartoDB, or Carto nowadays. This is Spanish. I think this is also Spanish. I'm sure there are much more, but well, with these ones, I guess you have enough. And here you have two layers. One is a satellite image, and you can see the information you have in your map here. This is the satellite image, and here you have the polygons that represent buildings. And buildings are mapped here according to their use. This is in Italian, but I see that it says there are churches, there are different things, and each building here is a line in the table with several characteristics. This is another open source data, so in this case it's a web service, so you can add data and edit the data directly in the web without any installation in your PCs. And nowadays they call Carto as such, and it's a Spanish company. And again, you can do maps here. You can edit. You can do the layouts of your map, and then you can share it on the web. You can produce maps, and so on. This is the other one. It's very similar to ArcGIS, so it's map info. Here again, you have all the information you have in your map. Here you visualize the elements, and each element here has a line in the table. This is Idrisi, the one that I told you that is more useful for raster type of data, so satellite images, because there are many tools in this software for the analysis of this type of data. But I guess for you it's more interesting the vector representation. So the previous type of representations, like this one, I think is most useful for you. And here is the one that I mentioned, the Esri software. It's called the ArcGIS. And well, here are they have many resources on the web, and this is a web page where they select the best maps according to their standards. They do contests of maps, and then they publish these maps on the web. So if you want to take some ideas on how to produce your maps, these are a good inspiration. Most of the things I already explained. So you have the map, you can open the table, you can see what information is in the table. You have many tools that you can use for the process you want to do with your data. If you want to analyze the data, there are many ways to do it. You have extensions that come with by default, but you can also add new extensions. Some of these extensions you need to pay. For example, the network analysis. If you want to perform routes to see how much does it cost to get to one point to another, you want to do a matrix of distance and this kind of things. You need this extension here, and this is paid.
And is there any attribute or layer, and we call it that will let you edit voice, like a voiceover?
Yes, I think so. Yeah. Yeah.
Okay.
Pictures, voices. Yeah. I think so.
Did any of the software?
I'm not sure about the other one, but
this one, yes.
This one for sure, yeah.
Yes.
And this would be interesting for web pages, for example. If you publish your map in a web page, so you have something that you can click and you listen.
This is a voiceover.
Yeah.
Great.
One question, could it be interactive? I mean, like GIF or someone? Because we were thinking of like making a map and putting it sort of with data and everything, but as you click, you can see like interactive. You click and you see the information you want to know, or there are options. However, if the program is only 30 days, so we have to make it under 30 days, or rather we have to make further.
Well, I think what you can do with this program is that you produce your map and you produce the information you want to see every time you want to click something. And then you export this as a service and you put this in a web page, let's say. So afterward, this has no license. What you do after you export your map and you put it in a web page, this can be used forever.